Hi, I'm Dr. Robinson. We are going to now look at Desmos, a very engaging tool for looking at mathematics for your students in the K-12 classroom and any sort of STEM classroom. So we begin by typing at desmos.com, desmos.com. Then we click on Start Graphing, and let's just kind of see some things that this tool can do for you. First, it can work with functions. So if you give a function like y is equal to x, then it graphs y is equal to x. Do y is equal to x plus 7. It graphs that function for us, y is equal to x plus 7. I could also then maybe look at a different function. Y is equal to maybe 2x plus 5, right? But students could do this all day, but maybe they want to look at comparing different functions. More importantly, how about look at if I had a parameter like m, and notice when I put m here instead of a 2, now I'm allowed to change that value of m by clicking on Add Slider, click on m, and now m is a parameter that I can change. So as I slide back and forth, this constant here changes. I can do the same thing for b. Now we have the classic slope-intercept form by adding a slider for b. First, again, I change this to b, and I click Add Slider, and now not only can I change the y-intercept, but I can change the slope and the y-intercept. Right? So you can imagine making up an investigation where students look at slope and y-intercept. So now, let's say instead of just a generic function y is equal to, one thing you can do is we go up to our original y is equal to x plus 7, and I can change it to f of x is equal to 7. Now, why would I want to do this? Well, now it highlights the fact that y is a function of x. So that means I can call on the function f of 6, and it automatically tells me it's 13. So that means you can now figure out what the value of that function is. I could also make a new function, g of x. G of x. Close it. It thinks that g is a slider. Why would it do that? So g of x, I want it to be a function. Let it be equal to. So now instead of x plus 7, maybe I do x minus 7, right? So we see this other function. Then maybe to make it more interesting, we change the first function to 2. And then maybe we change this to, maybe I change it to all of that divided by 2. So I did divided by hitting Shift and question mark to do the divided symbol. And so now I have two functions, f and g. And if you think about it for a little bit, those two are inverses of one another. And how could I check it? I could do f of g of x and hit enter, and notice you get y is equal to x. Or I could do g of, Control Z. Control Z still works. So now I could do g of f of x to really show students that, again, there's that line y is equal to x. I took these two functions and their compositions, and because I got x, I know that they are inverses of one another, right? Because I got it both ways. Cool. So some things that we can do, well, you can click here to remove a graph if you don't want to see it for a second. You can come over here to Edit List, and notice now I can edit this list. When I click on the red, I could make it a dotted line if I wanted to. See how it changes? I can make it a dashed line, or a dotted line. I can change its color to green, purple, whatever you want to do. So that can help for different types of visualization. So now they're both purple, which is not helpful. At any time, if you want to delete a function, you can delete it like that. So in general, we can let students know about families of functions. For example, I could do y is equal to a, and so it doesn't know that a is a slider, so if I just do y is equal to a, it thinks a is equal to 1. So how could I force it to be a slider? I do not know. I would actually have to look at that. So I don't know how to force it to be a slider. Let's say I made it M. Would it know? Wow, why is it doing that? Let's try this. Try f of x is equal to a. Good. Now it knows I want to do a slider. So f of x is equal to a. And I can do x minus h. Make that a slider. Do squared. So there I did shift 6 to get up in the exponent and then hit 2. Now I hit the next arrow to the right. I can do plus k. And so notice every time I made a slider. So now I can see what a does to this function by changing my value of a. I can see what h does by changing my value of h. And I can see what k does by changing my value of k. So again, students can, instead of being told what a does, they can find it out for themselves, doing an investigation that you can create for your students. So now let's say we've made this cool function investigation for our students and we'd like to save it. Well, we will handle that in the next video.